This transfer learning only need last a layer or output layer to be modified. So transfer learning, we usually only modify the last output layer because these early layers has already uh, learned the general features. But what is transfer learning? So in transfer learning, we use the uh, pre-existing model. We use it for our new task. Like for example, in the ImageNet, um, we use the model of ImageNet uh, to be able um, to learn. I mean to predict the two the two animal like dog and cat. So we use the pre-trained model um, because the pre-trained model has um, the patterns already learned the patterns that it needed to predict those classifications, right? So it has like multiple patterns of this one, and any different thousand of patterns that it needed to combine to identify if it's cat or um, dog. All right. So let's say how layers um, behave. A neural network learns in levels from the early layers. This one, uh, very general features. Um, by the way, the ImageNet consists of millions of available images. That's why it has a lot of possible patterns that it could be learned on during the training. So the middle layers has the combinations like patterns, parts of the objects like that. The last layer is just a specific like um, from digit one to nine. It's a fully form. So why only change the last layer? Uh, when you use the pre-trained model, the features extractor is already good. Why? Its loss is the train loss and the validation loss is proven to be um, to have low loss, and it has great accuracy when it comes to predicting something. So these features often work across a class. So next is only the task changes. Like for example, the old task classify 1,000 objects, but the new task classify only need 5 animals. So we only mapping from features labels, so it's updating. So from the 1,000 um, objects like this here, imagine that it is 1,000 classification. We turn it to five classification, which is the 5 animals. But before that, we're going to train this last layer, and I'm going to freeze the previous layers. So we need the model could learn what it needed to predict, like this whole object like that, like cat, dog, bird. So I needed makes it faster uh, and less data needed. Training all layers expensive plus needs a lot of data. And why we needed to to train it again if its accuracy and validation is good enough. And besides, it came from the large data sets, like millions of data that is available and trained on. That's and For sure it learns a lot of different patterns that we contributed across the layers and neurons to predict the task that you needed or the classifications. Let's talk about this example. Imagine a model trained on an ImageNet. The ImageNet is known for its large data sets, billions of data sets. It already knows edges, shapes, textures, and object parts. And it only need system activation to light it up, and adds a positive contribution to predict uh, the, the task or classification that you wanted to predict. Let's say classify cats and dogs only. So you have only two output neurons output layer, but before that you need to to train that last layer. You don't need to relearn edges or shapes. You just change the last layer to say that this feature is cat or dog. So important things. It's not always only the last layer. It's not always the last layer to be trained on. Sometimes you also fine tune the deeper layers, the other layers. So if your new task is very different, like medical scans or normal photos, um, those different tasks might not um, might not included in the image net. It's not the the data that was trained. It is an unseen data that is trained on. That's why we needed to train or fine tune the other deep layers and unfreeze them and freeze the others. So then you could freeze the early layers, adjust the middle layers, and train the last. So here's the big idea. Transfer learning works because of features reuse. Layers is general knowledge, the last layer task specific decision.